Well, Naveen, I'd like to make a quick introduction first. Naveen Verma, the co-founder and CEO of EnCharge. I am thrilled to welcome you.
Great. Thanks a lot, Justin. It's great to be here.
Well, as the audience is well aware, never is it my first time talking with somebody, and it's fun to be able to pull back the curtain on conversations that we've had in the past and be able to allow them to experience some of the wisdom and challenges that you've experienced along the way. And this is one of the conversations I've looked forward to for a long, long time. And so you've got a really unique background after dedicating over a decade to your education and earning your PhD in advanced computing. I'm always curious, was there a moment in your life when you said, I'm going to be an engineer? This is a path I want to take.
I think I can definitely trace back to that moment, and it's something that sort of came for me even before I sort of started down the path of engineering. Right, I grew up at a time when, hey, listen, if you were a kid who was good at math and physics, you kind of went into engineering because it was something that you could do with your life with those interests. But that's not really sort of the kind of inspiration one potentially could take away from a field like engineering. And so I actually got into college at some point and I went into engineering, but eventually thinking that really what I wanted to do was law, but I would start to do engineering and so on. And at some point, and it was about my second year in college, I was in a program where kind of my view about engineering really changed. And it changed because really what happened there was I was really presented with just a bunch of problems to go and work on. And I realized that what engineering is not is just something that you do if you happen to be good at or interested in math and physics. What engineering really is an extraordinarily powerful bag of tools and skills that can allow you to be extremely creative and can allow you to express that creativity in extremely powerful ways through the creation of new technologies, through the creation of new fundamental principles. And when I realized that engineering is really about that creative process and enabling that creative process within oneself, all of a sudden it was a great inspiration for me and set me down a pathway that I'm now on.
Well, part of that pathway is a really interesting one. It sounds like maybe all along it wasn't part of the plan to become a professor. Now you're getting to inspire the younger minds. Could you tell me a little bit about the journey to your professorship?
Yeah, that's exactly right. I went into graduate school from undergraduate. I had the great opportunity in my undergraduate to do a bunch of internships at really great companies, both startups, small companies, and big companies. And they were both very, very fulfilling in various different ways. But I came out of that kind of saying, having gotten exposed to some of these real world problems, I really feel like I want to be able to give myself a little bit of time and space to think about those problems in a way that isn't just pressured by kind of delivering this thing, sort of in the next quarter or in the next two quarters, because the problems seemed really, really important and really, inspiring to me. And so I felt like, maybe the right thing for me to do is go into an environment that gives you that time and space, which was, academia. And so off I went after my undergraduate to go do a PhD. Even early in my PhD, it wasn't clear to me that I wanted to be a professor. I was planning to go, do a PhD and take an industrial R&D sort of position. But I think as I kind of went more and more along the way, I kind of recognized that sort of having the time and space and freedom to think about problems without an immediate pressure of, sort of delivering a product against them was quite a powerful thing to be able to do. And I felt like it could lead to, sort of opportunities to really, really confront the big problems. And so relatively late in my PhD career, I decided I wanted to go and become a professor and give myself that opportunity. I did at that point recognize that there's a pitfall with it, right? If you give yourself too much freedom, you can go off and work on, kind of esoteric and problems that maybe don't, sort of have the same potential for really impacting the world. And that was also not something that I wanted to do. But I found the right balance, and I found the right way to sort of run a research group that worked for me in terms of the things that mattered to me, and that's kind of how I went off.
Well, a lot of that research over the last 11 or 12 years has been in advanced computing. And so in that research, clearly you're a thoughtful but also a passion driven person. Was there a time when the light bulb went off when you were said, aha, that analog computing could be transformative?
Yeah, and I think that the way that happened was very much by being problem focused. So I kind of decided that I really wanted to give myself the time and space that would allow me to focus on really big and deep problems, hopefully to come up with really big and deep solutions. Now, of course, when you do research, you do a lot of research, and you don't always come up with solutions that work, and that's just the nature of research. But one of the things that was very, very important to me was to stay, even as I became a professor in my research group, stay very, very engaged with real world problems. I deeply value and deeply appreciate the collaborations I had with industry, really working with them to understand what the real world problems are, but then to also bring a perspective of not just what do those problems look like today, but where are those problems and challenges heading, so that I could really start to think about, sort of fundamentally, how are we going to address those rather than just, sort of the most immediate thing in front of us. And I think the, sort of approach that we're using today at EnCharge, which involves analog computing and in-memory computing, two things that I think are very critically related, was not one that was inspired by, sort of, a drive towards analog technology, or really a drive from a technology at all. It really came from, sort of my view of where the problem of AI compute was heading, and how this is going to quickly get out of hand if we let it run off in this way. And really, Jen, thinking about what are architectures and approaches that would address that. And analog happened to be part of a critical part of the solution in this journey that I've been on. So it really came from working the problem out backwards rather than from some, sort of bottom up technology inspiration.
Absolutely. And one of the things that I've always just been drawn to about you, Naveen, is that you're a co-founder and CEO while maintaining your professorship at Princeton. And a lot of people have tried to pave that path before, and it just doesn't work. And you've been able to do a remarkable job of that, of being able to keep a foot in both arenas. Can you tell us a little bit about the secret sauce and the way you've been able to do that?
Yeah, in my view, the most important thing here has been self awareness. And by that, what I mean is recognizing, sort of by having a background as a professor and now wanting to have the impact that I feel I can only have by creating a company and getting deeply engaged in the company, and the particular position that drives me towards is to be, the CEO of a company. The really critical thing is to recognize the self-awareness that helps me recognize what my limitations are, what are the things I'm really not good at, and what are the things that I am really good at and uniquely good at because I have this background of a professor. And so I think, that self-awareness gets you to a place where you recognize, hey, listen, the typical things a CEO would do, or a traditional CEO would do and would be expected to do, may not be ones that I can address naturally. And so in that case, how do we as a company address them? And so it's both self-awareness, but also having the right team around me that really aligns with those strengths and weaknesses, so that where it's needed, those very close, in my case, co-founders could pick up and sort of address, some of the things that otherwise a traditional CEO would have, but that I just don't have, and that then allow me to bring, sort of to bear the unique strengths that I have as a professor, which I also think have been, in my view, really critical superpowers in being at least the kind of CEO that I want to be or hope to be, and that I think has been meaningful and useful for my company.
Absolutely. Well, and I think that one of the things that I have found in this industry, really across the board in all industries, is the number one superpower that a CEO can have is humility, which being able to have that self-awareness to understand where weaknesses are is clearly displayed there. All right, let's pull back the curtain. Tell the audience, what is EnCharge building for those who are not aware yet?
So at the end of the day, EnCharge is building chips, processors, really computing platforms, because it's both chips but also the software to run AI inference with much greater efficiency than we can do with today's systems and technologies. And to do this, and the reason that EnCharge exists, we need to have a very transformative approach to how we think about computing. And at EnCharge, we do. I think the reason we exist is because we did have a breakthrough, like what I believe is a real breakthrough in my lab. And it was many years ago. And you can imagine that when you have a big breakthrough and it's transformative in all the ways that sort of this problem requires you to be, that it's quite disruptive. And so you have to take the time to fully de-risk it at the fundamental technology level, at an architecture level, at a software level, and then sort of really transition from de-risking a technology into the full system to then starting to solve real customer problems. And that's been the kind of journey that we've been on at EnCharge. Our fundamental breakthrough is around a technology called in-memory computing. It turns out that in AI compute, we have a two-sided problem. If you look at the last 10 years, we've really seen an explosion by a factor of about 10,000 in the amount of operations that the state-of-the-art models require. And so that means we need systems that are much more energy efficient than what our traditional technologies and systems have been. But we've also seen an explosion in the amount of data by about the same factor, about 10,000x over the last 10 years. So we also need architectures and technologies that can fundamentally solve for data movement bottlenecks. And in-memory computing, it turns out, is one of the, I think, few architectures that can simultaneously solve for both of these problems. I should say, can potentially simultaneously solve for these two problems. And so that's what we're doing. We're rooted in this particular technology, and there's a lot more to say about it, but let me leave it at that for the moment.
Well, so analog compute was kind of relegated to this interesting research subject, but there were so many DIMC, the digital and memory compute companies that were founded and coming up. For you, I guess, twofold question. One, why do you think that there's been such a resurgence in belief and popularity in the analog and memory compute, and how are you fundamentally doing it differently?
Yeah, great question. So I think that there's a lot of excitement about in-memory computing in general. And like I said, it's one of the very few architectures that can solve the two-sided problem that we have, can solve both of those problems simultaneously. I think, I've done a lot of research in in-memory computing. It's an area that my group has gotten a lot of recognition and has generated a lot of results and insights. And I think one of the things that I think is quite broadly understood now in the industry is that fundamentally, digital in-memory computing is just the same technology. It's just digital computing. And you would not expect, and we do not see in the industry now, any real advantages compared to real standard digital acceleration for digital in-memory computing. And I think that this has been verified in sort of peer-reviewed articles and publications. If you look at in-memory computing, the way it solves the two-sided problem is it says, hey, listen, let's take our data and keep it in memory and not access all of the data one by one, because that's expensive to do. It turns out the operation that we're interested in doing, matrix multiplies, give us a very interesting opportunity. They involve a big parallel operation. So you do multiplication, multiplication, multiplication between the elements of an input vector and the elements of a matrix, the weights of a matrix. But the key is then you do a big reduction operation. You accumulate all of the data along one of the dimensions of the matrix. And by doing that reduction, by reducing all of that data to one result, by doing this accumulate, you only have to communicate out this one result. And that's how we solve the data movement problem. What digital in-memory computing does is it says, you know what, let me take the adders that do this accumulation and basically insert them inside the memory. What we find in practice is that the memory no longer looks like a memory. It just looks like the same digital operation that you did outside the memory. And so you lose the advantages. At the end of the day, you're fundamentally still processing zeros and ones. And that's good, that the whole industry went to digital because zeros and ones, that gives you a lot of margin against noise that each of your, sort of signals might have. And that's what allows us to scale to 200 billion transistor circuits the way that, sort of we're building today. But you can see that you eliminate the ability to represent all of these signal values in between. And so we've known for decades that analog, which gives you back that ability, can be orders of magnitude more efficient, and breaks the fundamental loss of efficiency that you get from fundamental efficiency that you leave on the table in digital. The challenge with analog, and the reason we've sort of loved the thought of it but never really been able to make it work, is because now you're once again sensitive to noise that you might have by representing all of these signal levels that digital helped you mitigate. And so the big breakthrough that EnCharge had was to solve the noise problem. And the way that we do it is we say, hey, listen, semiconductor devices, transistors or RAM cells or flash memory cells are great, but they're noisy. You change the temperature and the current through them changes. They depend on material parameters, things like mobility, that you can't manufacture two devices to exactly match on. So they're messy. And what we do is we say, you know what, we're going to do this in-memory accumulation, not by using the currents through semiconductor devices, which you can add up and sort of do that data reduction, but which is noisy. We instead are going to use these devices called capacitors. And what are capacitors? It's a fancy name. It's really just a metal wire sitting next to another metal wire, which it turns out when you have these metal wires, they couple through an electric field. And they actually allow you to also do an accumulation, but using charge rather than current. And what's really important about these capacitors is, first of all, you get them for free. These metal wires exist in any foundry technology. If you fabricate your chips at TSMC, you get these metal stacks on top of your silicon. If you fabricate them at Global Foundries or Samsung, you always get these metal stacks. So we can build these. What's important is these capacitors don't depend on temperature. They don't depend on material parameters like mobility. They're perfectly linear. They only depend on geometry, how far apart the metal wires are. And it turns out that in CMOS processing, geometry is the one thing that we can control exceedingly well. It is the reason we can build 12, 7, 5, 3, 2 nanometer transistors because of this geometric control that we have. We don't need anywhere near that precision for these capacitors, by the way. We need hundreds of nanometers, not kind of nanometers, single nanometers. But this allows us to now create a device for analog compute that is extremely precise, extremely scalable as the technology nodes advance, and that doesn't require any special process options. You get it for free in the technology. So that was a big breakthrough.
Well, speaking of breakthroughs, your team recently released the EN100, so congrats on that. First of its kind analog accelerator for on-device computing. How did it feel to bring the product to market, and how is it going to change computing?
It's been a process. So it certainly does feel like a really critical moment for us as a company to now, sort of have things that we're going to be very shortly delivering to our strategic partners and customers and so on. But it's been a series of very carefully taken and deliberately taken steps. So we built really the architecture, sort of in its fundamental form, was the result of, sort of something like 5 generations of silicon, many of which were built in the research domain. And then eventually, one that now started to really focus on real customer problems and real customer roadmaps and make sure we have the right, sort of features in our software and in our hardware. And that's really what EN100 is. It's the evolution, of all of these steps taken very carefully to now something that is very specifically directed at, a commercial use case and problem and so on. So it feels very good to take that next step. On the other hand, it feels like, the natural next step. But I think what's critical is it gets us to the point now where it's not just us internally banging our heads against, the question of how to build this and solve it, but to now really start to engage with strategic partners in bringing products to the market. You alluded to that question, and if I look ahead, even from where we are today, that is a long and careful process that we're going to have to go on. Because of course you take these chips, you integrate them in systems, you work with all of the application developers, and there's all of that careful work that needs to be done. But what's exciting for us is this is no longer just about looking inward and building this technology, banging our own heads and beating ourselves up. It's really about now, sort of the collisions that we have with our key strategic partners in the ecosystem outside.
Is there a specific engagement you've had, a commercial engagement that you've had that left you just fired up?
Yeah, I would say that the market we're pursuing and the partners we're pursuing it with, we arrived at because of the inspiration that it gave us, right? And what we're focused on doing today is putting very advanced AI capabilities inside what we call client devices, so laptops and desktops and so on. And on the one hand, it seems natural. The data center is a place where AI was deployed, but now, these are the next adjacent devices through which you access the data center. So as you start to think about some of the cost, some of the privacy security concerns that various enterprise and consumer use cases faced with leveraging AI in the data center, and you start to think about how you can break through those, this becomes very exciting. But I think it just also becomes very concrete, right? I think one of the things we're seeing with AI is that it becomes much more valuable when it's customized, when it's personalized to specific users or to specific enterprise use cases or workflows. But such customization and specialization often involves fine-tuning these models to my specific data, to my specific workflows. That is not something that I want to have done and then be hosted in the data center or in the cloud. So just thinking really not just about putting AI here, but the ways in which AI can now be much more personalized, much more customized for specific workflows, and the way in which that increases its value. Thinking about how that gets unlocked by putting AI in these devices has been incredibly inspiring, right? Now AI, I think, really becomes valuable on a whole other level.
If we shift the conversation a little bit to values, one of the things that is near and dear to my heart is the development of technology in a responsible way. And responsible AI is at the forefront of news, et cetera, whether it be, information security, governance, power consumption. What's your stance on responsible development of AI, and how does EnCharge how is EnCharge going to impact that?
That's a great question. It is certainly something that I think about a lot. It's also something that, this comes back to that self-awareness, that I recognize that I think we as a society are not well prepared to holistically and deeply think about. And I think we all first need to align to how important that question is, and then participate in the way that we think we can add value to the conversation, but sort of in a collaborative way. And that means we got to have multiple people involved in the conversation. I think the way that I see it at EnCharge is it's something that's deeply on our minds. It's something that we worry a lot about and are concerned a lot about. But exactly what the solutions are to it are not clear, and I don't believe are going to be solved within our four walls. And so where we find ourselves is in great awe of this technology. And I think many of us working at EnCharge believe that this is a technology like no other that we've ever seen in our careers in terms of the ways it can impact society for good and for not good, for bad. And so we are very committed to being a part of that conversation and, sort of doing the work that we would need to do to deliver solutions to the ecosystem to address, sort of the AI for good interest. But we also recognize we're not sure we know all of those answers, and so what we submit is we will be committed to being a part of that conversation and thinking about sort of how the things we can do can impact that as together we gain a better understanding of that, which we need to do with some urgency as a community.
Now these conversations can oftentimes come across as a highlight reel of achievements. And oftentimes, actually, this question is one that I'll shudder at because people are ill-equipped to answer. But your humility, I think, puts you in a really unique place. And so I'm excited for the answer to this. So if you were to take the last 4 years and encapsulate it, there's got to be missteps, mistakes, failures along the way that would have you shaking your head, but not hanging your head. Can you point to one that maybe has been transformative in a positive way for the company that now that you look back on really helped shape the company in a positive way?
Yeah. So first of all, you're very right. There's not one example. There's many examples, and I think for us to all be honest about those examples and to all be very sensitive to identify those examples is a really, really critical thing. Now, you're asking me to identify one, and if I was to do that, I think one of the things I would say is, look, startups are a critical source of innovation, and each of them is going to have their own kind of innovation, nature of innovation, and pathway for that innovation. Ours was a very interesting one, and one that I think is unique because I think every startup's pathway is really unique. Ours is one that came out of really sort of deep fundamental research, a very differentiated, a very transformative fundamental technology, but one that we needed to have a phase transition around to go from research to building products, and delivering those to customers, and having the drive and the focus on that engagement with the customer, that sort of prioritizing the success of the customer. Those are traditionally two rather different things, being a researcher who can think broadly and, sort of is, trying to solve research problems, to building and executing against a real product. And we had to find the right balance because of the trajectory that we needed this technology to take to become a real product. And figuring out how do we build a culture around really moving from sort of a research state to a product state is one that was a real sort of journey for us. Understanding sort of how our teams should work together, how the right balance between team members who have experience and sort of ways of thinking about the problem in one way versus the other way need to come together. And there's a lot of impedance mismatches that happen there, and figuring out how to sort of value both sides of that, and have the right engineering processes so that we can be productive on both sides of that was a real learning experience for us. And making sure that everyone was aware. If you come from a background of product execution, well, what is it going to look like to work with somebody who comes from a background of research and R&D? And if you're from research and R&D, what does it look like to come work with somebody to whom you have to hand off towards product execution? I think understanding and building a culture and building engineering processes around all of that has been a really critical learning for us.
Well, you're obviously doing a phenomenal job with it today, and I love this transition talking about culture because I'd like to talk a little bit about talent at this point. And this is a really neat opportunity for me to learn because you do have a unique perspective, both being a CEO and a professor. What do you think hardware companies could be doing a better job of to help nurture the next generation of engineers?
Yeah, I mean, I think about this as a professor, and I think about it now also being in industry leading teams, right? And it's the following. The job of being an engineer today is so much harder than it was, in my view, 10 years ago, right? So my life as an engineer is going to be so much easier than the folks that are coming 10 or 20 years after me, because systems have become so complex. And the applications of technology in society have become so much more diverse and broad. And so I think the thing that we really need to do to nurture the next generation of engineers is to make sure that they have an understanding that what we're building here is not just a box that has a certain set of specifications, and when you go and execute against that, you've been successful as an engineer. The fields are extremely dynamic. That box and that spec are going to constantly change. that change is managed through the way that every layer of a technology stack interacts with every other layer of the technology stack. So really understanding that full system, and really understanding at the end of the day that the system is used in some real application, is an important insight for engineers going forward to have, that I don't think we've necessarily sort of intrinsically built into the way that we bring up engineers, either in the educational system or in the mentorship systems that we have in industry. But I think really getting people to understand that that's, those are the realities of what I think it takes to be successful in the AI hardware space, as an example, exposing the younger, and upcoming generations to that and having them participate in that is, I think, the critical aspect to nurturing the future engineer.
I couldn't agree more. And I used to be able to preface this question with a specific number. The last time I saw it was like 215, but I feel like we should have like an odometer, because there's a new AI hardware startup, it seems like every hour, but there's a ton of them that are trying to build similar technology. And so you're in a competitive space. How have you uniquely attracted engineers to EnCharge?
Yeah, I think at the end of the day, people attract people, right? I think when I founded EnCharge together with my co-founders, I've come from deep research. I was super excited about this fundamental technology, and it was a big breakthrough. And I thought that's what would drive me personally every day, that we're working on this, amazing new technology. All of that's moved to the background, right? The thing that inspires me every day at EnCharge is the people that I work with. And so I think the way you attract the best people is you've got to have the best people. And so that's something that is an aspect of culture building that needs to start at the very beginning. You need to start by having that solid foundation where, sort of there's a core value around engineering excellence, engineering creativity, engineering openness. And I think you need to let it build from there. And I think if you start on the wrong trajectory at the earliest stages, it's very difficult to recover. So I think at the end of the day, what attracts people to EnCharge, and we've been very grateful for the team members that we've been able to attract, who inspire us every day. But what attracts those people is the people that already exist in the company and with whom they want to work and interact.
Well, that aligns so well with an ethos that I try to share with founders early on, is that A players attract A players and B players attract C players. And so to keep that talent density high, you have to have a critical eye, and sometimes, most of the time, an incredible amount of patience in that too. Because just as important as attracting good people is, frankly, repelling those that you don't want to be at the company. And part of that is truth telling. Is there a truth about working at EnCharge that really fires up the people who are there and that excites them, but might make somebody that wouldn't be a good cultural fit to think twice about joining or applying?
Yeah, I think that the truth about EnCharge that can sometimes be a challenging and daunting one for people is that, we had this big technology breakthrough. If you think that this thing that happened down at the sort of transistor and circuit level is going to carry the company forward, you're mistaken. Everything that we do now has to be built and designed in a way that's optimized around a very new way of fundamentally doing computation. And that means assumptions that you may have had as a highly respected and comfortable in your position engineer at NVIDIA or at AMD, are assumptions you got to be comfortable with, sort of dropping and learning from scratch. So you will be putting yourself in an uncomfortable position where you are, sort of thinking about, sort of architectures and engineering and problem solving, a little bit from scratch. And listen, you're going to have the support around you to do that, but you're going to have to be willing to, sort of not fall back on the things that were comfortable assumptions for you, because it won't allow us to build the thing that ultimately works and harnesses the strengths across the different layers of the stack. So, you're going to have to, that's a change that comes from within, and it pushes you into a little bit of, sort of out of your comfort zone. And it's also a lot of working with the people around you, because no engineer today can know the entire stack up and down as much as we'd like to think we can. It's too complicated. So you need to be able to rely on others who are also willing to be, sort of equally out of their comfort zones, but also willing to, sort of work together and engage with you and help you and support you. So I think that those are two aspects that, I'm not sure engineers are asked to bring to the table in the previous roles that they've been in all the time.
Keen insight. Let's think for a moment that somebody possesses those attributes. They're a rare bird. So somebody who's watching this, who might be, and they're probably very happy where they are if they possess all those attributes and well taken care of, what would you say to prompt them from curious to talking to you?
Yeah, I mean, I guess what I would say is I can quite honestly say this field of AI that we are in is like nothing I've seen in my career. It is the problem of our generation, and probably the problem of many generations. So there's an enormous opportunity here. The creativity you have, the skills you have, don't sell themselves short. Don't sell yourself short with those. Go and do something that you think is going to be really, really impactful. At EnCharge, we have this particular view on that and a particular technology around that, and that's just one way of thinking about it. But the opportunity to push the barriers here is not only present, it's required. And sort of now is the time to do it, because it's quite a moment in history with this kind of technology and the ways that I think it will be impactful. So go and sort of see what you can do that will maximally appeal to your curiosity and inspiration, sort of without the inhibition of sort of here's where I'm comfortable.
You talk about a generational problem, multi-generational problem. When we talk about that big picture, it gets me thinking about legacy and impact. If we're to fast forward 5 to 10 years from now, pick any data point or point in time along that continuum, what dent do you hope that EnCharge has put? What legacy would you like EnCharge to have in that AI problem solving?
That's a good question. I don't necessarily think about it, or I don't necessarily, sort of cast it as what's our opportunity to create a legacy. I think that's too grand a way for us to think, right? We're engineers. We got to solve the problems that we see in front of us. I would say the problem that I want to see us solve is to really, at the end of the day, take this very powerful technology AI and make it usable, put it in a format where it can actually be used in as many meaningful applications and workflows as possible. And I think today, the technological complexity of this really powerful thing AI limits it from being that. And I think there's a lot of things that are going to be required to break that limitation. One critical piece is going to be efficient hardware. There's ways in which we would like to use AI, but they're very, sort of data sensitive. And at the same time, we need very complex and advanced models. So it's hard to use them locally on device with the energy constraints and the space constraints that we have, but, with the kind of advanced AI models that we want to leverage. Those are the kinds of problems that I hope EnCharge can solve. At the end of the day, it's a very powerful technology. For it to, sort of fully be usable across all of the applications where it has potential, I think a lot of us are going to have to come together, and I think EnCharge has a piece in that.
I have sensed that from day one when we talked, is that you also have the same mindset that I've held. Is we've also, it's a rising tide lifts all boats, and it's going to be an ecosystem problem, not one big winner. So I'm gonna ask you one more question. We talked about you being a CEO. We talked about you being a professor. You're so much more of that. As much as you're comfortable pulling the veil back, can you tell us about who you are outside of work? What do you like to do, and any other roles that you might hold that we're unaware of?
I'm basically just like anyone else. You take away the CEO, you take away the professor, and the next thing that comes to mind that occupies a lot of my mind share is being a father, sort of a husband. I happen to have kids right now who take a lot of attention and a lot of time in all of the ways that I love to give attention and time. And I think that that's really important, right? It's important for all of us to think about what we are in, the problems that are occupying us in our day jobs, but also what we are outside of that, because it makes you a little bit more whole as a person. And I think that that makes you better at all the different roles that you might be playing. So that is the one that I think, between that and the other things you mentioned, there's not a whole lot of hours left in my day, but those are all good hours spent.
Well, that's awesome. And I think that answer actually could be overlaid on people's career. If I were to give advice to people from a career perspective, is find a place where all the problems that you're pouring into are problems that are ones that you like to pour into, that all the ways that you like to give your time. Because if that's the case, then you're not really going to work. So this has been incredibly, incredibly giving. So I appreciate the time that you've had to share. I can't wait to do it again soon, hopefully in the next 6 to 12 months, and we can talk about some further wins. But until then, again, the community thanks you.
Thank you very much, Justin. I enjoyed it very much.